try to start this again. So I started making a video and then we got interrupted. So the idea is that we're looking at what is happening in this reaction in terms of like looking at the sugar. We don't really care as much about it going from a circle to a non-circle, from Hayward to Fisher, in terms of like looking at the reactions itself. The big thing is looking at what is occurring. So we're moving that phosphate group over, which is where this comes from. In terms of what we're looking at for this, like that's where that exchange is actually occurring. And so I wrote out like 1, 2, 3, 4, 5, 6 for the 6 carbons or whatever. And then 1, 2, 3, 4, 5, 6, and an option in red, just so you can kind of see how we're going from the cyclic molecule to the flat molecule. So anytime you see ATP, ADP, that's involving phosphate, which means that phosphate is a substitution reaction. It's always going to be done by like a kinase or a phosphatase in terms of like taking it on or off. Don't have to know that part of it, just know that it is a substitution, and that's done by a transferase protein. So that's where this is getting put on. So you always look at what's changed. So you go from an OH to an OPO3. So that's what's getting changed. In terms of this next reaction, you can see that this has gone from being an aldehyde to a ketone. But all in all, nothing else has really changed. So this, as CHO, remember, is that. So all we're doing is we're just moving that double bond down by 1. With the idea that with that being moved, but nothing's changing, it's an isomerization. And that is done by isomerase. Really easy to remember which protein it does, what protein does it, if it's like the exact same name. It's ones that are different that always throw me off. So
Can you say that one more time?
the ones that have the different names, yeah. So the ones that have different names are the ones that throw me off. But it's an isomerization, so it's an isomerase.
So we're adding and wait.
We're just moving. We're just moving this down.
Oh, okay.
So we're moving this from having a double bond right here to a double bond right here.
Gotcha.
So it's being converted from an aldehyde to a ketone. Because an aldehyde has like hydrogen on the end of it, and then a ketone has carbons on either side of that carbonyl group. Okay. C, we can see that it's doing something with ATP and ADP, and we're seeing that it's taking this OH group here and trading it out for this phosphate group. So the idea is that if there's a trade occurring, that's our substitution, and the big giveaway is this ADP, ATP. So this is transferase, which is a substitution. And the big thing is like, we already kind of learned about the phosphate transferases, that's kinase and phosphatase, we learned those through so those should be fairly knowledgeable for us. I don't think it'll ask about the test though. So now that we're here, we have this reaction D. And he basically on his like thing, he said like he was trying to tell you that like D is one reaction, and then you have D leading into reaction E, with the idea that D is basically taking this molecule and saying, okay, cool, I've got a phosphate over here and I've got a phosphate over here, so let's cut this in half. So in the process of cutting this in half, we are basically like splitting this into 2 different pieces of that same thing. And I can't remember what he said this was, but I think this is, I think he calls it an elimination.
It's,
I think that's what he calls it. So that should be what it is.
what number is this? Or letter, I
This
should
is
say.
letter D.
D is elimination.
Yeah, elimination. So the idea is that you're eliminating each half from the other half. And that's where this idea comes from. It's because you're cutting, you're eliminating it from each from another half. It's not a hydrolysis because you're not using water to cut this in half. You would have to draw in like a water molecule coming in order to cut it in half. We're not doing that. So because this is an elimination, it is lipase. And then this reaction E is basically taking this molecule and rearranging it into that molecule. Because you're moving this to the end. Which tells us that if we're just rearranging, we're doing what? Summarization.
Yeah, let's do that. I thought that's what it was too. Is it something else? Or is it a summarization?
Should be a summarization. Yeah, a summarization.
Okay.
Which is isomerase once again. Okay, because you're just rearranging. And then when you're looking at F here, when you're looking at F, you're adding a new oxygen onto this. So what is it whenever we're adding a bond to an oxygen?
Addition.
Redox.
Redox.
Oh,
Anything with oxygen or hydrogen.
Anything with oxygen,
I'm
is
sorry.
redox.
okay.
It's okay. So redox, oxygen. So the idea is oxidoreductase enzymes do that, which is really nice because it's basically just a reverse of what the name of the thing is. So redox is oxidoreduction. So reduction, oxidation, oxidation, reduction. It's named that way so you can understand there's a flip. As one thing is getting oxidized, the other is getting reduced, all that kind of stuff. So now that we've added this oxygen, we're gonna now look at what we're doing next. And we're seeing that we're moving this here. And I think in the process,
It has
he has
ADP to
ATP and ADP involved in here. And the ATP involved. So the idea is that I think that he wants us to understand that this is something involving like the removal of a phosphate and then like reapplication of that phosphate. So it's like an isomerization or whatever, but the idea is that it's using a transferase to do this isomerization. So I don't actually know what he puts as the answer on this.
It's substitution.
He puts substitution.
Yeah.
And the idea is that he doesn't really want you to care as much about the aspect of this being moved and more about this aspect. So you see ATP, ADP, this is transferase. I'll show it up here because I can't have room otherwise. Which is a substitution. Kind of what's actually going on here is that you remember that we had all of this stuff happening and then we split it here. So we've actually got two of these. And so what's actually happening in the body is that more likely than not, on the other end of this phosphate group is probably the other one of these. So they're probably like conjoined over that phosphate group, more likely than not. And so that's why he can say that we're losing a phosphate group is because they're probably each on the side, but he doesn't want to draw it in that way because we only really care about one half of that at a time. So this is for G. And then we've got H here, which, I'm gonna move the H over, that way it's like not confusing if people really look at this later. H. So we've got H here, and we kind of have to just look and see what is changing. So So the idea is that we're going from here to here. So the top half of this isn't really changing, but we're losing this OH group here. And in the process of losing that OH group, we're gaining a double bond for this carbon here, for these two carbons. So the idea is if you're losing an OH group, you're going to be doing an elimination reaction. Theoretically, you could say it's a redox, because that's really what it is. You're breaking bonds to that oxygen, but he has it as being an elimination because really what you're doing here, you're just eliminating, you're just taking something off, or whatever. So he says elimination, but it's technically just it's a combination thing. It's a redox elimination. And so the idea is we don't really care about the redox part of it, so it's an elimination. So again, that's a lyase. I don't know, I'm assuming that if he gives us something, if he gives us this exact thing on the test, or if he gives us something very, very similar, you could be like, hey, like this is involving oxygen. You said to like think about oxygen as being redox reactions or whatever, and I could think he could give it to you, but just understand that if it's removing something, it's elimination. That's kind of the main point there. Yeah. And then the last thing is you're just looking at seeing that they're removing this phosphate group again. And again, it is showing that we have ADP, DP, ATP occurring, with the idea that we are removing that phosphate group. And at this point, we've done this like 4 times. So what is ATP and ATP always? Substitution and transferase. So yeah, sorry it's a hot mess with stuff everywhere for people who are watching this on the video, and for you guys too. Like, I just ran out of room. So, yeah, so that's the general idea. And even then, like, I'm not great with these. Like, it takes me a little bit to like sit down and actually like think about what's going on. So just take your time and just pay attention to what your first thing is and what your second thing is in terms of like what you're seeing. And pay attention to if there's ATP or ADP involved. There, I'm gonna stop this because that's still super loud.